In this video I want to show how a measurement of the transconductance is performed. The transconductance of a tube is in fact nothing else than the slope of the anode current versus the grid bias curve in any point of this curve, or in mathematical terms the first derivative of the anode current versus the grid bias. So a measurement of the transconductance will obviously always start with a measurement of the anode current as a function of the grid bias, and here we have a set of those curves for the EL84 tube. The simplest way to determine the transconductance would have been to simply draw a line between two consecutive measurement points and determine the slope of this line. However, differentiating a curve like this very easily can result in a very noisy transconductance curve. Therefore I've chosen a slightly different approach here, and that is to first fit a polynomial through the data points and then to analytically differentiate that polynomial. So the first step is to fit the polynomial. To show how that is done, we first switch off the line here so that we only have the markers showing the data points, and now let's switch on the right axis the anode current fit. And what you see here is obviously a very bad fit because we have chosen a first order polynomial. The trick is now to increase the order of the polynomial in such a way that a perfect fit is obtained. So we play a little bit with that, and what we in the end find is that a fifth order polynomial gives a near perfect fit to the measurement data. Once a perfect fit is obtained, we can select here the derivative of the fitted anode current, which already gives the transconductance. And we see that for a grid bias of -7 volts here, the transconductance of about 11.4 is obtained, which is an excellent value and exactly the value specified in the datasheet. We can again also turn on the line for the anode current, and then we measure also the anode current, 48 milliamps, with a transconductance of 11.4. Exactly the values from the datasheet, which again shows what a beautiful and accurate measurement tool the uTracer is. In the same way, the inverse of the transconductance can be plotted, and this can for instance be used to determine the output resistance of the tube from a set of output curves, that is the anode current versus the anode voltage.